us to the far reaches of this black hole to learn more about what's inside. If you're interested in keeping up to date with news about the universe and its surroundings, subscribe to our channel. Be sure to like this video, share it so it reaches more people, and turn on the notification bell. It all started in 1916 with Albert Einstein's general theory of relativity, who was the first to predict the existence of these entities. Although the term black hole was officially coined 50 years later, some scientists already believed in Einstein's theory while others dismissed it. It was in the late 1960s when researchers were studying the constellation Ceres X1 that they noticed something amazing. A strange bright blue star was emitting X-rays, revealing that it was no ordinary star. This blue star was orbiting around something giant and dark. Upon further investigation, it was discovered that the X-rays were not moving on their own but were attracted to the mysterious entity that the star was orbiting. Whatever was at the center of that orbit turned out to be a powerful force that consumed everything around it. At that point, science gained official evidence that black holes were a reality. But little did they know that things were about to get even more extraordinary. The initial discovery of Ceres X1 turned into a series of additional discoveries before it was realized that there could be approximately 100 million black holes in our Milky Way galaxy alone. However, due to their incredible difficulty to be detected, we still do not have an accurate and precise number. According to current estimates, this number is in the several millions, which makes them even more important objects of study. According to most physicists around the world, a black hole is an entity where anything that enters it is compressed astronomically until it becomes a singularity. To simplify it into simpler words, they have explained that due to the way black holes work, if someone were to fall into one, they would stretch like spaghetti, slowly dying in this form before reaching the final spaghetti form. This is one of the scariest parts of the research done on black holes and is also what makes everyone want to know all the details. Although the closest black hole to Earth is 1,500 light-years away, this information still raises the question of whether black holes can actually swallow the Earth whole. In 2021, scientists managed to publish the first clear photograph of a black hole, specifically the black hole M87. The black hole was photographed for several nights in a row, and with each image, researchers collected more and more evidence about it, revealing the existence of three fundamental layers in its structure. That's right, a black hole is not just a lone hole in the void. To delve into the depths of its mystery, you need to understand the first two layers. Let's break it down. First, there is the outer event horizon, a boundary that surrounds the mouth of every black hole. Once something reaches this point of the black hole, it cannot escape and is either trapped there or is pulled deeper on its journey to the singularity. The singularity, on the other hand, is the central core of the black hole where gravity is so intense and constant that literally nothing can get out of there. To escape, something would have to travel at a speed much faster than the speed of light, which has so far proven impossible. It is important to note that gravity on Earth works differently. If it were similar to black hole gravity, we would not be able to survive the way we do. Once we have crossed the event horizon, we have in front of us black holes, the great ultimate enigma, the singularity. This is the point at which most of the mass of the black hole is concentrated, where everything is compressed to become practically nothing. Physics as we know it stops working inside black holes. Both on Earth and in most of the space we have explored, it is absolute chaos. And the worst part is that each black hole is unique, with a different gravitational force and attraction. You could gain complete knowledge about one black hole only to have to start from scratch when you explore another. It's like a never-ending puzzle. The problem is that scientists cannot study black holes in the same way they study stars or other planets. They can't just look at the radiation they emit along with the dust and gas that surrounds them. They cannot send something like the Voyager probe into the interior of a black hole, since, as we have previously established, it would be crushed in when it reached the singularity. Simply put, our only option is to study these massively powerful phenomena in space in 2 dimensions since we cannot get close to them. The fact is that so far, we have not been able to get inside the singularity to really find out what it is, because as we have established, it is practically impossible to travel faster than the speed of light. However, this does not mean that the scientists who have been studying these giant masses of mystery do not have their own theories. They have numerous theories about what could be inside a black hole other than the singularity. One of the most plausible theories is that black holes are not simply masses of nothingness but that beyond the event horizons and the beginning of the singularity, there could be something else. This theory suggests that black holes could be like doors, but we don't mean a door leading to a common place. We're talking about the possibility of traveling between galaxies and universes through them. Another interesting theory posits that black holes could be a glitch in the matrix. Using this metaphorical reference, If we could develop technology capable of faster-than-light travel, we could open our way through one of these black holes and explore what lies on the other side. However, these theories are still in the realm of speculation, and scientific exploration continues in search of more concrete answers. It is possible that the singularity is not simply a void but a wormhole leading to another galaxy. It would be a shortcut in interstellar travel, something we never thought possible. This idea raises the possibility that we might not be limited to exploring only the planets in our own solar system. We could look for ways to traverse these black holes and reach the galaxies they take us to. If this turns out to be true, it would mean that limitations once assumed to be insurmountable might not be as impossible as previously thought. At the opposite end of the spectrum of theories, we find one that rejects the existence of black holes altogether. Tokyo-based scientist Enrico Raldi and his team have been trying to make sense of these phenomena despite how strange they seem. They've come up with a simple theory that explains all this madness. According to this theory, black holes are simply holograms. Now, holograms as we know them are holographic images created through technology, but here not all holograms are the same. Any visual discrepancy or illusion can be considered a hologram as well, and when we're talking about the vast abyss of space, anything is possible. This theory that black holes are holograms isn't as wild as it first sounds. It's based on a complex but fascinating concept known as the holographic principle, which comes from string theory and quantum gravity. This principle suggests that all of the information contained within a three-dimensional space, such as the volume inside a black hole, can be represented as encoded information on a two-dimensional surface, like the event horizon. Imagine watching a 3D movie with your special glasses on. While the image appears three-dimensional to you, the actual information exists on a flat screen. Could the universe itself, and particularly the black holes within it, be functioning in this way? The idea is that everything inside a black hole, every piece of matter and energy that has ever fallen in, is somehow encoded on its outer boundary. This perspective turns our understanding of black holes inside out, quite literally. Instead of the singularity being the central storage point of all that collapses into a black hole, it might just be the illusion of a central point. All the real data could be smeared across the event horizon. If proven true, this would completely alter the laws of physics as we know them, redefining our understanding of space, gravity, and time. There are even more theories about what happens when you fall into a black hole. One such theory is the infamous firewall paradox, which suggests that instead of being gently stretched into spaghetti, you will be instantly incinerated the moment you cross the event horizon. This controversial idea proposes a wall of high-energy particles, a kind of quantum firewall, exists at the event horizon. If this is true, it challenges the principle of equivalence in general relativity, which states that you should feel nothing unusual as you fall freely through the event horizon. But the debate rages on. Many physicists refuse to accept the idea of the firewall because it violates long-held assumptions about quantum mechanics. Instead, others lean toward more mind-bending concepts, such as the idea that black holes preserve information in ways we don't yet understand. This ties into Stephen Hawking's information paradox, a long-standing conflict between general relativity and quantum theory. According to quantum mechanics, information can never be destroyed. But if a black hole swallows a book, a person, or a planet, where does that information go? Is it lost forever, or does it somehow survive? In his later years, Hawking proposed that the information is not destroyed but is instead preserved in the radiation a black hole emits, what we call Hawking radiation. As the black hole slowly evaporates over unimaginable spans of time, the information that went into it might be released in a scrambled, nearly incomprehensible form. If this is true, it suggests that black holes are not the ultimate cosmic shredders we once believed. Instead, they might be nature's strangest kind of library, one that hides its contents in quantum code and releases it only in bits and whispers over eons. Let's take a moment to imagine what it would be like to stand near a black hole, not close enough to be pulled in, but within its gravitational influence. Time would move differently for you than it would for someone farther away. This is due to gravitational time dilation, a phenomenon predicted by Einstein's theory of general relativity. The stronger the gravity, the slower time passes. In fact, if you hovered near a black hole for what felt like a few minutes and then returned to Earth, you might find that centuries had passed. This is not science fiction. It's a tested and confirmed effect of gravity on time. The movie Interstellar touched on this concept, portraying a planet orbiting close to a massive black hole named Gargantua. On that planet, every hour equaled 7 years back on Earth. That concept is rooted in real physics. The closer you are to the immense gravitational pull of a black hole, the more time distorts. This isn't just a curiosity, it has practical implications for space exploration. Future missions involving black holes must account for these time shifts, or risk losing entire crews to the temporal abyss. Meanwhile, back in our own Milky Way galaxy, astronomers have pinpointed a supermassive black hole at its center, Sagittarius A star. It lies about 26,000 light-years from Earth, and despite being 4 million times the mass of our Sun, it is relatively quiet. But don't let that fool you. Supermassive black holes like this one shape the galaxies they inhabit. In fact, many scientists now believe that galaxies form around supermassive black holes, not the other way around. These behemoths dictate star formation, galactic spin, and even the distribution of dark matter. They're like the hidden conductors of the cosmic orchestra. The discovery of Sagittarius A**''s location in nature was a breakthrough achieved through years of observation and the use of advanced instruments like the Event Horizon Telescope, EHT. In 2022, EHT released the first image of this giant, showing us a glowing ring of hot gas swirling